Hey guys, welcome back to our virtual STEM highlights on Tuesday mornings at 11. It's Elizabeth here, and I am here once again with our awesome intern.
Hello, I'm Elise. I'm happy to be here
Yes,
once again.
we love roping her into doing our virtual STEM highlights. She is a pleasure to have this summer for our STEM summer program. Speaking of our STEM summer program, though, if you guys have been unable to attend in person, you guys are 100% welcome to utilize these virtual STEM highlights as your passport punches. Like, you can send us an email at education@aerospaceutah.org and let us know that you've been watching, and we will send you your passport with the punches, things that you've been doing. Let us know what you've been doing, if you've been following along with the experiments, so that you can graduate from our STEM summer program. Because we're so excited. We are aware that our STEM summer program in person has been mostly booked. And so we're just excited to be here and glad that we get to do this on Tuesday mornings. Yeah. On that note, this week we're covering a topic that we do get to cover in our STEM summer program, but we're going a little bit more in depth and doing a bit of a different experiment this time. We're talking about electricity and electrical currents. So I think we all generally have an idea of like what electricity is. What on the top of your head, like what do you think of when you think of electricity, Elise?
Yeah, off the top of my head, I think of lightning, of charging my phone, light bulbs, just a lot of energy. I know that we use it to charge a lot of things, all different sorts of things. It's a big topic.
Yeah, we can use electricity. It's very versatile. We can use it for a lot of different things, which is funny because you talk about lightning and charging your phone as the same as like, which is crazy because they're so different. But they are both electricity. Right? That's really interesting.
Yeah.
It is weird to think about because I don't think that we can use lightning to charge our phones.
Yeah,
but
it wouldn't end up very
good. It would not end up going very well. So electricity is, in its most basic form, the energy of charged particles. So all matter, everything that we have in the universe, can be broken down to one small particle. And what is that particle?
An atom.
It's an atom, yes. And atoms have these little tiny things that are going around the outside of it, constantly floating, and these are called electrons. Now, electrons have a negative charge, and they don't really like being stuck all together with too many of them. So I'm going to say something. I'm going to have you guys repeat after me the words, opposites attract.
Opposites attract.
Good job. Opposites attract and likes repel.
Likes repel.
Yes.
We can hear them.
We can hear your spirits joining us. Yeah, so opposites attract and likes repel, right? So that means that if we have a bunch of electrons, a ton of these negatively charged electrons all in one place, they are likes, they are similar, they're all the same thing. And they repel each other. They don't really like each other. They want to find their opposite. They want to find something positive, something positively charged, aka protons, another part of the atom, and they need to use something in order to make that happen, right? So, Elise, have you ever been like walking along in your kitchen or somewhere around your house and like maybe like dragging your socks along a little bit and then you touch a surface and like feel that zap?
Right. Yep. Not pleasant.
It's not like the most pleasant, especially when you don't know what's going to happen, right? That is basically the electrons in your body or that you've been gathering around yourself, finding their opposite, finding equilibrium. And it's a type of electricity when that happens. But is that the type of electricity that charges our phones and powers our houses and gives us light?
I don't think so. I don't think it is.
What is the difference?
So there are two different kinds of electricity. The first is static, and that is when an object is charged with electricity, but it doesn't move, and it doesn't have anywhere to go unless it sits there and it builds up, and then it's forced to discharge somewhere, and it doesn't have a direct conductor. And that's the same like lightning and the static when we rub our feet around or when we rub a balloon on our hair. And then the other electricity is current electricity, and that's what we use to charge our phones and use with light bulbs. That has a direct conductor where we can harness the electricity and use it for different types of energy.
Okay. So what I'm hearing you say is that one of them uses a conductor specifically and intentionally placed there for its purpose.
Right.
And one of them is not moving. It's forced to sort of release that energy when there's too many electrons and it has to discharge itself.
Yes.
Okay. So what are some things that can be used as conductors?
I think that metal is a good conductor, copper and tinfoil. It's a really good conductor.
There is some tinfoil on this table. Okay, so you talk about metal, copper, tinfoil. We have a little bit of metal in our bodies, don't we? Are our
true.
bodies conductors?
I think they might be. Should we test it out? Let's test it out.
Okay, let's try it. Let's try it. I think they
Okay.
can possibly be made.
Yeah, let's experiment. So right here I have a Tesla coil, and when I put my hand on it, it gives is attracted to the electricity in my body. So I'm going to use this tiny little light I have right here, and when I hold on to it, nothing happens. But if I have Elizabeth take the other end and hold on to it.
Oh my gosh,
up.
I don't know if you guys can see that. Hopefully you can because the light's bright in here, but there is a light going on and off. If I let go, it goes off. Okay, so if I touch you on your wrist, it goes off. Wait, so that means that maybe it's finding an easier path to go through and then it doesn't need to use the light.
Right.
Okay, so I can't touch you. I have to make the electricity go through the light bulb.
Yes.
Okay.
And that can make it, if I do this, it's a light switch, open and close. This is a closed circuit and open circuit.
So not only did you just become a light switch, you just proved that our bodies can conduct electricity. That's crazy.
Who would have thought?
I'm like, oh, okay, well, I'll be really careful next time a lightning storm comes around.
It's true.
Because it can use me to get to the ground or get it somewhere. Okay, so, but we want to do this on an elevated scale because honestly, I really like lights, and between Elise and I, we don't have enough of us in order to
create a lot of
lights. So we're going to do this in a different way. We are going to create a type of circuit that conducts electricity through multiple light bulbs or over a course of a series. So things that you're going to need in order to make this experiment work include a piece of paper, some aluminum foil or tin foil right here, some tape, a 9-volt battery, and we've taken some old Christmas lights that we can't really use them anymore. Some of the light bulbs are out, they're just not very nice anymore. And we've just cut them off of the wire, and then we cut some of the plastic off of the wire to make sure that we had that copper wire exposed. This is because the copper is a conductor, and we need to make sure that conductor is touching our circuit and it's able to actually make that flow happen. Okay, so we did do this experiment just to test it out before and just to see what would happen, but we want to do it on a bigger scale. But just to show you guys, we have some aluminum foil, we have a light right here, we have a 9-volt battery, and all I'm doing, and notice that this 9-volt battery doesn't have enough power in it to hurt me, so I can stick it right here, and let's see if this will work.
Here we go.
Whoa! Okay.
So bright.
It is really bright. So one thing that we will say and suggest here is that you please have a parental supervision or adult supervision of some kind, just to make sure that you are completely safe. The 9-volt battery doesn't have a whole ton of electricity in it. It's probably not going to hurt you, but just to be safe, to make sure that you are being safe, please don't go anywhere near any electrical outlets or anything of that kind to make sure that you are taken care of, that you're going to be safe. One thing that I'll mention too is you don't have to use a 9-volt battery. You can use any type of battery, but these are easiest to use because if you can see on the end, it has both a positive and negative end right here, which means that you can just stick the one end down. So just be aware of that. But before we get too far ahead of ourselves, let's take some aluminum foil and start folding it. And here's one of the funniest things. So the shiny side of the aluminum foil for some reason is a little bit more conductive. I could not tell you exactly why right now. I looked it up and they said it's a little bit more conductive. So it doesn't, I don't think it really matters too much, but you know, for the sake of trying, I'm going to do the shiny side out and just fold my aluminum foil so that it's sort of like this is a long conductor. It's sort of like a wide looking, weird, you know, wire in a way. And in this case, it's a wire. So then what we need to do once we have our aluminum foil is we need to place it in the shape of a circuit around a piece of paper and tape it down. So what we've done right here is we've taken some paper, and do you want to hold up that side? And we have created what will be a series circuit. Now, if you look at our aluminum foil, you'll notice, oh, they've got all this aluminum foil, it's taped down, but they have all these weird blank spaces right here. That's where we're gonna put the lights. If you remember how when I was holding that light with Elise, if I touched her, the electricity had an easier path to go through to get to me. It didn't need to go through the light bulb. It's the exact same with the aluminum foil. If you have a light sitting on the aluminum foil, it won't light up. There's an easier path for it to go through. But if you put it in between, you're sort of forcing the electricity to go through the light bulb to light it up. All right, so we have a path right here. We need to create our actual, like finish the circuit by putting those light bulbs on. Okay, so we're gonna finish our circuit.
It's the best part.
And I'm gonna take a couple pieces of tape and hand it to you. And we just need to take these wires and just make sure that they are on both sides, touching the aluminum foil. Okay, now I've got one. I think we have enough blank spaces on this to light like 7 or 8 light bulbs. Now, we have not yet tried it with multiple light bulbs like this, so I think it can be done, but we might need to use a second battery just in case.
We're prepared.
We are prepared.
Let's see. Stuck my
Okay.
tape together.
Oh, tape.
Unfortunate.
Okay. All right. Ooh, okay. 1, 2, 3, 4. Guys, I love
gosh.
Christmas lights so much.
Me too. I cannot wait to see what this is gonna look like. Let's see. Do you
Okay.
have a new decoration
Yeah.
for your
We'll
house?
hang it up in our. Yeah. Yeah.
A new nightlight.
Yeah. Perfect.
See?
Okay. We just
Almost
need.
done.
Oh, you've got that one, and I just need to do the last
This
one.
is where the battery's going, right?
Yeah, that's
Okay.
going to be where the battery goes. Perfect. Now, you can kind of see ours is a little bit bigger. We decided to do it with 2 pieces of paper because we wanted to get more lights on our board. You can do this with cardboard, with probably some poster board if you would like. And you can see right here, so now we have a bunch of Christmas lights.
Oh my gosh.
Hooked on here. And there's one more blank space right here where we need to put that 9-volt battery. That 9-volt battery is going to be the connector to get these lights to turn on. Okay, Elise, do you want to do the honors? Let's try it sitting down and then we'll see if we
Yes.
can do it standing up
Okay.
so we can show everyone.
All right, here we go. Oh. I don't know. Maybe I'm doing it
I don't
wrong.
think, let's see.
Maybe not have enough space. I think it might be too big of a space.
Well, it also might be, we might not have enough power in the battery. So let's
Oh,
see. We
that's
might need
true.
to do 2 batteries.
Try it again.
Ooh, okay. So 1 battery is not enough.
Mm-hmm.
Let's see if we can do 2. And let's do opposing ends. Interesting. So that means
very
our
interesting.
circuit, what's up with our circuit?
Is it too big?
Is it too big? That's a good
Too much?
question.
I don't know.
Well, maybe we should close it and see. Let's make it smaller.
Okay.
Okay,
Let's go for it.
let's troubleshoot this. Let's make it a little bit smaller. Maybe there's not enough. Okay, so I'm cutting this in half.
Is that too
Okay.
big?
No, I think it's
Okay.
probably okay. And let's take this light bulb, connect it over here. This is sort of fun. You get to experiment and see how many
It's
light bulbs
true.
it will power up. We know it can power up 1 light bulb, but can it power up 9 of them? Huh.
Interesting.
What's up with our circuit?
I have no idea.
Let's see. I wonder if is there any way that it could be finding an easier path to go through that does not include
That's
this?
a good point.
So if you're not getting electricity in your light bulbs, there's a good chance that somehow the electricity is going somewhere else. So we can compare to this, and we can also, let's try this once again with 2 batteries. And we need our opposite ends sticking next to each other. Okay, that didn't work. Hang on. All right. This is interesting.
This is very interesting.
Yeah, because we know that it does work with 1 light bulb. I want to know, is there too much tape on it? Maybe.
I was wondering that too.
This one had quite a bit of tape. Let's see. Okay. Should we try fewer light bulbs then again?
Let's do it.
See if we can cut it down. Fewer light bulbs, and we'll make sure that they are connected. This is fun. I would have no idea how
I don't know either.
I would have no idea how many light bulbs it can power up. Showing just how much or how little. Yeah.
I wonder if you could even have different places to put batteries, some more batteries maybe?
Yeah. Ooh,
Not sure.
interesting. Okay.
Is this one coming off? Or is this one? I just took this off, and I was like, oh no, maybe I should have left it.
I'm gonna cut. Well, this is this one in the corner. I think is probably the easiest one to take off.
Perfect.
So yeah, I think you're okay either
Sounds
way.
good.
But let's get that tape down again. Okay, so we have 3 light bulbs this time. We just need to connect these right here. Or maybe, do we have too much aluminum foil?
Oh, we'll show
Thinking
you
how thick is this aluminum
what we're
foil?
doing right here. You can see. So this is what is kind of going on here. We've cut off this end, and we're trying to connect this right here. If that.
Yeah, so we're using
makes
less
sense.
light bulbs, more conductivity. And let's tape that down right there in the 2 spots. Okay, let's try it one more time.
Okay.
What? Well, we know it
no
worked.
idea
This
what
is
we've
the
done.
exact same.
It's true.
Interesting.
This is very interesting.
Well, now I have an idea. Okay, hang on. We have a circuit that's
understand where you're
already
going.
sitting right here. And I'm going to take this and I'm going to... Ooh, I wonder if the wire can't be touching the paper.
Oh.
If the wire is at any point touching the paper on any
Kind
of
of
them.
doing it a little
Like
bit.
right there. Because this one has... The wire definitely doesn't touch the paper. This is... Never would have known unless we tried this again.
Either.
This is the fun part of experimenting, guys.
It's true.
Okay, so we know it worked.
Oh!
Okay, so it did work. Okay, so it worked with this one. So right here, we added an extra light bulb with that circuit.
Yay! Oh my gosh.
Okay.
That must have been it, the paper.
It must have been it because on this one, we
It's
allowed our
that.
wire. On this one, we allowed some of our wires to touch the paper.
I can see how maybe they have to be fully on the tin foil, like 'cause some of these, how it kind of half off.
Yeah, because they're half off. So there's, once again, another place
Yeah.
for the electricity to go through,
That makes sense.
which makes it so that they have another conductor. Okay, while
That's
you,
good to know.
I want to see if this, I just want to do one more light bulb because I really like lights and then we can be done.
I think that'll be cool. Yeah.
That's right. Okay. And I think that means that it helps to make your gaps a little bit smaller
Yeah, that's
because then there's not as much of a gap for your... Oh, well that makes no sense. Okay. I put down too much tape. Okay. Just to explain, I'm noticing that I put some tape down, and I'm realizing that I'm trying to connect my copper to the tape and not to the aluminum. And that is not conductor to conductor. So we need to put the conductor next to the conductor because tape is an insulator, right? It's the opposite of a conductor. It does not conduct electricity. Okay, do you want to try this one?
Sure.
Okay.
Alrighty.
All right, crossing my fingers that 3 will work. Okay, we can do 3 lights at least.
Yeah! Oh my gosh, it's gorgeous. It's better than I ever imagined.
Is it? Oh, perfect. All right, here's our challenge for you
Yay.
guys. Make yourself a circuit. You can do a series circuit. You can also create a parallel circuit by creating lines in between, in the middle, and see how many light bulbs you can fit into your circuit with the electricity. We got 3. We know 3 worked for sure. We suspect that you can do more. Just make sure you've got that connectivity in between the light bulb and the aluminum foil.
Yes. It's good to know.
Yeah. So let us know how many light bulbs you can possibly get on your circuit board.
Yes.
All right. Thank you guys for joining us today, and have a fantastic week.